So good morning, everyone. Welcome to the presidential address of the 2024 ISSLS. So today we're here to celebrate the remarkable individual whose contributions have been the backbone of our society. I present to you the spine of our society, Dr. Kazuhiro Chiba. So in the early life of Dr. Chiba, he was born in Tokyo in 1958 as a first child of Seiichi and Yuko Chiba. Even as a child, he exhibited a natural curiosity and impeccable posture, traits that would serve him well in his future career. Dr. Chiba's early years took him around the world. From 1962 to 1965, he lived in San Francisco, and from 1971 to 1973, he resided in London. These experiences not only broadened his horizons, but also gave him an early lessons in international relations, from kindergartens to crumpets. Back in Japan, Dr. Chiba attended Keio High School and later Keio University School of Medicine. His love for adventure saw him joining the mountain climbing club and the ski racing club, where he spent most weekends and holidays in mountains. If it wasn't for the love of his mountains, we might have had the world's best orthopedic skier instead. It was during his time at Keio University that Dr. Chiba met his wife Mari in 1980. After 6 years of dating and endurance test, even a spine specialist would admire, and they married in 1985. Their partnership has been a cornerstone of his journey. Dr. Chiba graduated in 1983 and earned his PhD in 1994. His career has been illustrious, spanning from Keio University and to Rush University in Chicago. From resident to a chairman, he has proven that hard work has a good sense of humor that can get you anywhere. Dr. Chiba's impact on the field is immense. He has authored 268 peer-reviewed articles, 15 book chapters, and delivered numerous presentations worldwide. That's almost enough to fix every spine in Japan. His dedication to research and education is truly inspiring. Serving the secretary of ISSLS and leading the military hospital were no small feats. Despite being a kind-hearted man, it was comedy of contrast to see him as a chair at the military hospital. Providing life really does have a sense of humor. In 2024, Dr. Chiba retired, leaving behind a legacy of excellence and dedication. But knowing him, retired doesn't mean tired. We expect him to be active as ever, perhaps with even more time for ISSLS activities. This is a memorial birthday celebration with his wife Mari for his 65th birthday, and he is ready for a retired life, but we may not have him do that soon. So I invite everyone to join in and celebrating his achievement and contributions. Let's raise a toast, preferably with a straight back and good posture, and listen to his address. I invite you, Dr. Chiba, Kazuhiro Chiba, to the podium. Thank you.
Thank you, Dai, for kind introduction, and thank you very much for letting me give this presentation. It is my great honor and pleasure to give my speech to you. There's nothing wasted in my life. Actually, my life is full of waste, but I'm going to tell you about it soon. So here are disclosures, and I had fundings from many funding sources. And today I'm going to talk about my encounter with the disc and a little bit about intradiscal therapy for lumbar disc herniation, and then basic research that I have experienced, and development of new treatment for disc herniation. And lastly, I would like to give a message to ISSLS researchers. I graduated from Keio University, my university medical school, in 1983, so 40 years ago, and went directly into orthopedic residency program. And during the teaching hospital rotation, I met many cool spine surgeons. On the right-hand side, yes, is Dr. Mochida. He's a member of the society. They're all cool, so I decided to become a spine surgeon. I'm a simple guy, so. And at that time, lumbar disc herniation was the main target for spine surgeons. And lumbar disc herniation is a degenerative nucleus pulposus extruded into spinal canal through the annulus crack and compressing the nerves and causing variety of symptoms. And it's common between age a little bit younger than other common OAs, degenerative joint diseases. That's mystery. And when conservative treatment failed, surgery was standard treatment. And many surgeons said surgical outcomes were good or excellent. But there were few saying that long-term results of surgeries are only slightly better or sometimes equal or sometimes worse than conservative treatment. And surgeries are not without complications. Nationwide study in Japan revealed that patients who undergo surgery for disc herniation, 5% of them experience some kind of complications. So there were trends towards less invasive alternatives, and one of them was to make surgery less invasive using microscope or variety of endoscopes. And another trend was to manipulate the intervertebral disc itself and decompress the IVD, nucleus pulposus, and consists of nucleus chemonucleolysis and percutaneous procedures. And chemonucleolysis, as all of you may know, in the procedure injecting enzymes into the nucleus pulposus to decompress the nucleus pulposus intervertebral disc pressure and also protruding disc to relieve the nerve root impingement. And chymopapain extracted from papaya was the most frequently used enzymes, and it gained widespread acceptance in the United States and Europe. But soon it fell out of favor because of various serious adverse events like anaphylaxis and myelitis or paraplegia. So then came the era of percutaneous nucleotomy, which was invented by a gentleman in the right-hand side. He's Sadahita Hijikata, a big name of Keio spine team, and who was my mentor. And in this procedure, nucleus pulposus was piece by piece removed manually through the small working channel and doesn't have any adverse events like paraplegia. And he developed his own instrument, and this technique gradually spread to US and Europe. And various instruments were developed for this technique, including automated aspiration probe and motor-driven shaver. And some surgeons even performed disc fusion through this small channel. And concept of percutaneous disc surgery was established. But soon, this technique also lost its momentum because all these IDT, intradiscal therapy, is indirect decompression, cannot remove the herniated mass directly, and so indication is limited, and efficacy is variable, maybe around 3%, 50%. And most of all, it lacks evidence. There's no comparative study. And as you know, advent of MRI has revealed that many herniated disc regress automatically. So in order to prove if a treatment is truly effective, you have to compare that with placebo and show the superiority. And I started research on IBDs under the guidance of Dr. Hijikata. He was always saying that PN takes time and it's very burdensome for both patient and surgeon. So it's much better if you can treat them with one-shot injection. So the theme I got for my thesis was that to inject various substances into the disc and see how they affect the disc and surrounding tissues in search of a new chemotherapeutic agent. He was working in Tokyo Electric Power Company, TEPCO Hospital, in center of Tokyo, equipped with, it's a very rich hospital equipped with variety of facilities and dedicated personals. But I was working at the remote rural hospital, teaching hospital. So what I could do was to commute 3 hours one way, once a week to TEPCO Hospital and try to make preparation for my animal research. But most of the time, I just spend time in library, collecting the and reading the literatures on IBDs. So it was kind of a waste of time, I thought, that time. And once I started animal experiments, I did it like crazy to catch up. And I spent most of the day in laboratory and 7 days a week, no weekend, for almost 2 years. Intradiscal injection of various substances, sacrifice the rabbit, dissect the disc, and prepare the surgical, pathological specimens and microscopic observation. Repeat of that same simple work without using my brain. And same thing, endless repeat of the same simple course. But I lack creativity. I lack creativity, but I'm good at repeating the same thing without using my head. So I created many data and presented many papers. Many of them are Japanese, so I don't think you can understand. And I finally managed to write up thesis and get a PhD, but it wasn't a very, study that I can proudly present to others because I was not able to find any new agent for treatment. But then some of you might say it's a waste of time and effort, isn't it? But I don't argue with that. But anyway, I got a PhD, so I wanted to do more quantitative researches that my friends are doing, like biochemistry. That looks more fancy. I was stupid, so I didn't know the importance of pathology. People tend to perceive what others doing are cool, and biochemistry, I wouldn't do that. And also, from childhood, I have harbored my aspiration to study and work abroad someday, but I didn't have any overseas connections. And I encountered Dr. Masayuki Shinmei. He's a professor of orthopedic surgery in National Defense Medical College. He was renowned for his basic research, and he told me he has a lot of international reputation and connections. So I met him in my fellow's wedding, incidentally, and had a short talk, and he said, "Oh, I can introduce you somewhere, maybe Rush." So I said, "Anywhere I go." And in 1994, I went to Rush. And next year, 1995, Dr. Shinmei passed away by cancer. And I was so devastated because he told me that when you get back to Japan, you're going to be my staff. But anyway, he passed away. And at that time, I couldn't imagine. I was 20 years later, 2015, I became a professor of national defense. So I thought it was a God message telling me to repay his kind arrangement. But anyway, I went to Rush in 1994. I met Professor Gunnar Anderson, who made an excellent talk yesterday. And he gave me a freedom to do researches with biochemistry department, and also he helped me join ISSLS. At Rush, many people are doing cartilage research using the 3D culture of in alginate, all of you may know. But I didn't have any experience of biochemistry or chondrocyte cartilage research, but taking spine out of the rabbit is a piece of cake for me. So I did a lot of research, just replace the chondrocyte with IBD cells and culture the cells in alginate and looked at proteoglycan metabolism and collagen metabolism. And I don't go into detail, but my research results indicated that unlike chondrocytes, disc cells are very poor in producing the matrix that surrounds themselves. It's called cell-associated matrix, and that protects the cells from external stresses. So if you have thin cell-associated matrix, maybe cells may be vulnerable to external stress. So I thought this was a cause of early onset degeneration. And I also looked at age-related changes of these metabolism. I extracted discs from different age animals and extracted cells and cultured them in alginate. And I found that younger cells produce more matrix. And as cells get older, they break down this cell-associated matrix much quicker. So that means as cell ages, this matrix, protective shell of matrix becomes thinner and thinner. And I thought this could be a cause of progressive degeneration by aging. And I submitted this data to paper, in the journal. And review always said, show the proof, not just the graph or figures. So I had a little bit of experience in pathology. So I made these samples and resubmitted these matrix, cell-associated matrix are thicker in chondrocytes or annulus fibrosus and very thin in nucleus. And then my paper was immediately accepted. So I thought day spending on pathology wasn't a waste, it was meant to be. And I also did a lot of researches on growth factors and cytokine metabolism. And I even encapsulated whole disc in this alginate gel and find that this encapsulation will preserve the cells to, the phenotype of the cells. And also, I had a chance to submit a research proposal to Seikon Corporation, United States, describing a little bit exaggerating a big name in disc injection. And luckily, I got a research grant. And this opened the door to chondrolyase project. I'll come back later on. So as always, I'm good at repeating the experiment and making research and data. So I presented many presentations and wrote a pretty amount of papers. And at that time, I thought having nothing to do, just reading the papers at TEPCO Hospital, it helped me a lot when writing a paper and making a presentation. So it wasn't a waste of time. So life in Chicago was super. Chicago is a very nice place. This is the condo. This is the condominium where I live by the Lake Michigan. And it was so beautiful. I had visited many meeting sites and personal travels all around national park. I thought I would become a national park ranger rather than MD. And so it was a wonderful time. I made so many friends and peers. And after me, there was no one doing research on disc, but after me, there are many Japanese spine surgeons visiting Rush. And we were able to have sometimes annual alumni meeting of Rush. So after I went back to Japan, I was appointed as the head of spine team, and I continued research on intervertebral disc with my fellows. And this is Dr. Tsuji, who found that young NP cells make TIMP that inhibits MMPs to break down the matrix. And this is Nobu Fujita, who is over there. He's a ISSLS member, and he's serving as a program committee this year. He found that CD24 is expressed specifically in nucleus pulposus. And CD24 is now recognized as a specific marker for NP cells. And he also found that vascular end cell growth factor with its receptor is highly expressed in nucleus pulposus, vascular nucleus pulposus. And by shutting down this pathway, it induces apoptosis of NP cells, so it's doing something to protect the cells. And this is now Hosogane and Kato, Dr. Kato, and he's also a professor of Kyorin University in Tokyo, but he also found that estrogen and its receptor upregulates the matrix synthesis in synergy with TGF. And I also did a genetic research with Professor Shiro Ikegawa, who is a very renowned geneticist and also orthopedic surgeon. And we did, as you know, 99% of our DNA is the same. We only have 0.1 difference. And those variability is, in those variable DNA, most significant one is SNP. So using this SNP, we try to find the susceptible gene for disc herniation of disc degeneration. I started research with my few spine fellows, and that time was again a routine work, making diagnosis, obtaining consent, and making questionnaires, blood samples, and DNA extraction, the sequencing, same routine work. But soon, Yoshi Kawaguchi and Masa Kanayama, ISSLS members, and others joined this team. And finally, this project went on to international collaboration with Hong Kong team and Finland team, including Rino and Yarrow. So it's simple sequencing, simple but time-consuming work. And we found a SNP that has most significant difference between case and control. And we nailed down the gene that contains this SNP. And we are able to find a couple of potent genes like cartilage intermediate layer protein cell, or type 11 collagen A1, or thrombospondin. And we did some functional analysis on these. I won't go into detail, but what's special for our research was that we not only said we find this gene, but we did functional analysis and found what they are doing in the disc. So we did this. And again, we submitted these results to a variety of papers, including Nature Genetics. It was quite successful. But even after all these efforts on IVD, exact mechanism of IVD degeneration is still not known, and we haven't found anything that can stop degeneration. So I hear someone say, Kazu, your life is just full of waste of time. But I don't think so, because I have a chance to meet these nice fellows, my IVD research team. Once every year, we have a party and get drunken and speak about our stupid researches. I'm happy with that. And I also was able to make international and domestic colleagues, so many ones. And what's most delightful for me is that my spine team, deformity guys, brought this technique to address adolescent idiopathic scoliosis using this SNP technique to prevent such extensive surgery. And this study was even more productive. They find a lot of genes and published so many papers, including 5 Nature papers. And also, we brought this technique to find a susceptible gene to OPLL, that also has genetic implications. And we also were able to publish a lot of papers. So it's my great pleasure to see a tiny little step I initiated with my few fellows, expanded to so many research projects with significant outcomes. I hope someday they will lead to some clinical application. And go back to interdiscal therapy. These temporary craze but quickly faded. And there's one enzyme called chondroiase. It's a glycosaminoglycan degrading enzyme isolated from gram-negative rod Proteus vulgaris that's present in soil. And it has high specifically degrades chondroitins. But most importantly, they completely lack proteolytic activity. Dr. Iwata professor emeritus of Nagoya University. He was doing research on cartilage when he was a graduate student in late 1960s. And he was using this chondroitinase, and he recognized that this may be an ideal cheminolytic drug because it doesn't have proteolytic activity, but it can effectively degrade glycosaminoglycan chondroitin sulfate. So a couple of years later, he started experiment with the researchers of Seika Corporation. They injected this chondroitinase into rabbit, and they saw dose-dependent reduction in disc height and also intradiscal pressure. And if they injected it into the sheep disc, and they found that intradiscal pressure diminishes with dose-dependent manner. And if you injected both chondroitinase or chondroitinase and carmine to monkeys, you see both induce disc space narrowing, but chondroitinase is much milder. And looking at the histology, the staining for proteoglycan remains in chondroitinase, but not in carmine. This is photomicrograph. Carmine completely destroys the disc, but chondroitinase, you can see that the annulus laminar structure is preserved. And chondroitinase is much safer for nerves. They don't affect the nerve fibers, and they don't affect microvasculatures like carmine. And this is the experiment that I did. I injected intradiscal injection of both carmine and chondroitinase, and then extracted the cells and see how they behave. And cells exposed to chondroitinase has much higher ability to reproduce the matrix compared to those exposed to carmine. And this is a dog whose both hind limb was paralyzed by disc herniation. When we injected chondroitinase, the dog starts to stand up and be able to walk. So basic research results indicated that chondroitinase is a potent cheminolytic drug and worth conducting clinical trials. So we started phase 1 clinical trial from 2000. This is my buddy, long lifetime friend, Professor Matsuyama of Hamamatsu University. This is the first human study. We injected variety of concentration of enzyme into the human disc. And it's turned out to be, and it has already been 30 years passed since Dr. Iwata's initial conception. And phase 1 clinical trial revealed that chondroitinase is feasible for single intradiscal administration if we choose the right concentration. So we went on to phase 2-3 clinical trial. This was quite ambitious trial. We, looking at trying to prove the superiority of chondroitinase over placebo at the same time, trying to find optimal dosage. So we selected 3 doses, and all doses were effective in reducing the leg pain and back pain. So superiority of these all 3 doses were, found. We were able to show that. But unfortunately, only 2.5 unit didn't make, marginally couldn't make the statistical significance, but was effective. And no adverse events were found. So we decided that 1.25 should be used for clinical applications. When we brought this data to agents, PMDA, that's something like FDA or something like FDA in US. And they said, we can't let this 2.5 insignificance go. So we argue that it's because of randomization process. They were a little bit more, bulging this. That's a little bit resistance to this chondroitinase. But in the end, it was not approved. So all 40 years of this basic and clinical researches so far has been in vain, waste of time. But we didn't give up, so we have to redo the clinical trial again. And this time, we concentrated on 1.25 versus placebo. And we found that significant difference because we already knew it, because it was proved already in the previous study. We just repeated it. Oh, what a waste of time and money, but we had to do that. And we published this data in Spine. This became the first drug with proven evidence of superior effect over placebo in IDT, any IDT. So this was approved in March 2018 and went into market. 50 years since Dr. Iwata's original conception and 20 years after beginning of the clinical trial. So if you choose right patient, the pain immediately go away after injection, followed by rapid regression of herniated mass. And we did a post-marketing service after 5 years, which ended last August. Approximately 25,000 vials were sold. And in this post-marketing survey, 4,300 patients were registered, and efficacy was around 70–80%. And 60% of adverse events were observed, adverse events, but most of them are just allergy, relaxed skin rash, or itching, or temporal low back pain. And there's only one anaphylaxis and no paralysis or death. So condylase can, if you choose the right patient, it can provide almost equivalent results to surgery, much safer and much less invasive. So for me, being able to deliver a new treatment that can help patients in the real world is so privileged as a scientist and physician. So last, I would like to give some not message, but how I think. And even if you think what you're doing is worthless, if you try to continue working on one thing, may, not 100%, but may lead to something worth later, but you don't know at the beginning. So continuing to pursue and stick to one thing like crazy may eventually bear fruit. So success is continuing to pursue something until you succeed. That's the word I like very much, who was made by Dr. Konosuke Matsushita, who was founder of Panasonic. And there's nothing wasting life. So ISSLS gave me a chance to present many papers, and I get a lot of critical but constructive feedbacks. I appreciate that. So being a member of this society gave me strength to move forward, insight, and warm help from many friends and collaborators. Thank you very much. And no, yeah. Oh, yeah. No, yeah. Please wait. I have a very important slide at last. So ISSLS made me realize the importance of science. This is the statement made by Professor Tatsuo Suda, a very famous researcher, in his final lecture at the university. Science treats researchers equally. Science nurtures researchers into global citizens. Science teaches researchers importance of solidarity or collaboration. And science is a job worth staking one's life on. I always print this on in front of my table and desk, and when I get depressed, I watch this and read this and regain strength. So ISSLS gave me a chance to serve as a member of a variety of committees and secretary and vice president. It was a tough job, but it's really worth it. And because it gave me a chance to make such invaluable, many friends that last for a lifetime. So thank you very much for letting me serve this wonderful society with full of true science and warm friendship as your president. And one more thing, wait. One more thing. I can't finish my talk without showing this. The best thing that ever happened in my life is that I met a pretty girl, went to her, and she's still beside me, always helping me, supporting me. and giving me a joy of life. And you know, this guy has a senile decay, apparently, but she's still beautiful. Don't you agree? So thank you very much, and I hope this talk didn't waste your time. Thank you so much.